Good morning. My name is Ray Henry. I am the Director of Business Analytics in the Monte Hoosier College of Business, and I'd like to welcome you to Business Analytics SaaS Days. There are a number of people that I would like to thank for making this event possible, including the College of Business and our Dean, Richard Reed. I would also like to especially thank our corporate sponsors, SAS, which has done a tremendous amount to make this event possible, along with KeyBank and Progressive Insurance, who have generously donated to make this event possible. So I would like to thank them. I have a quick change to the program. At about 10:50, we're going to add in a break for about 10 minutes. I think that that will come at a time that will be a relief to a lot of people. So we're gonna squeeze that in. We have several speakers today. The first will be Christian Nimsch from SAS, who will be talking about healthcare analytics in the age of big data, which I think will be a very interesting discussion of a particular application of business analytics. He'll then follow that up by talking about SAS's global data analytics and their approach to analytics, which I think will be very informative, particularly about a number of their projects and products. We'll then have a panel discussion, and we have a number of great panelists to provide an industry perspective on business analytics from a variety of industries. So that will be an opportunity to engage with this and to talk about some of the important topics in business analytics. And then finally, we're going to have an opportunity to look at one of SAS's new products that is particularly innovative, looking at visual analytics. So once again, I'd like to welcome everyone. And at the end, I encourage everyone to stay and enjoy some socializing and some hors d'oeuvres as an opportunity to network, to build our analytics community here in Northeast Ohio. So once again, welcome. And at this point, I would like to introduce Christian. Christian Nimsch is the head of the Center for Health Analytics and Insight at SAS, a strategic research and incubator group focused on scalable applications and advanced analytics across health and life sciences. As head of the center, Christian focuses on expanding and extending the SAS footprint in life sciences by identifying industry-specific business issues for which SAS can provide an analytics-focused solution. Today, Christian will be talking about healthcare analytics in the age of big data, followed by a discussion of SAS data analytics worldwide. Please welcome Christian Nimsch.
So, thank you. I always love addressing crowds like yours because it doesn't just remind me where I came from, but it also kind of shows that the path that I took was probably a good one. So where I came from, by my accent, you can tell I didn't grow up in North Carolina. I was born, and I did move here for college, a little bit over 20 years ago. When I first arrived, I actually wanted to study English and literature. Problem was, when you want to study English and literature, you kind of got to be able to speak English really well. Well, I didn't do that. So as an alternative, I figured, well, universal language is kind of math. So I focused on economics. I had a deep interest in that, and mathematics. So my undergraduate degree is in economics. I followed that up with what hopefully some of you guys are already doing and some other folks might have done in the audience. I followed that up with a master's degree in applied statistics and worked in a research think tank after that. And my entire career I've really spent in healthcare and or public health related. So I started off working for a think tank. We did a lot of work around public health issues such as weight loss, smoking cessation, substance abuse. Our clients were like the CDCs and some larger groups that were funding this type of research. I followed that up by focusing on the pharmaceutical industry. Did a lot of value propositions for innovative biopharmaceutical products. Earned my MBA during the same time. and continued to work in the field, ended up working with payers and providers in analytics. So I'm telling you that because I kind of want to connect with what your degree program is trying to accomplish, which is really kind of like get you ready for analytics. So in the early part of my career, I was an analyst. I was a SAS programmer. I was an applied statistician, so I was fingers on the keyboard. Later on in my career, I realized, especially when I started to work with pharma, that there's a huge disconnect between decision makers and the analysts. Generally, what we have seen is that analysts sometimes have a hard time understanding why they're doing what they're doing and what ultimately the decision will be based on that work. Can give you some examples. I would work on some reports that were, that I generated for the CDC, for example, and we sent them in, and you don't get a response. And then, hopefully, about a year later, you see your work being quoted in, one of their other publications, and wow, there was actually a reason why we did that. So, similarly, with the business, with the decision makers, they oftentimes have a really hard time understanding what can you actually do with data. How do you make analytics work for them? There's like a lack of transparency oftentimes, meaning that when they're presented with information, it might be tough for them to actually trust that. So that was one of the reasons why I decided to get an MBA, because I felt, well, that was actually a very nice way to interject and be as that interjunction between the analyst and the decision maker. So I just wanted to give a little bit of background in terms of where I've come from. These days, I manage our healthcare offerings. So I take a look at how SaaS is positioned in the marketplace, how our customers are using SaaS, and I look for opportunities to make SaaS more applicable. So what I'm going to be talking about in the beginning of our talk is really kind of like concepts around big data that we are picking up across the healthcare continuum. So we are talking about payers, providers, talking about pharma, commercial, pharma R&D, clinical trials, etc. For the majority of it, I'm going to be leaning a little bit more on the payer and provider side, but if you have any questions around applications outside of that, I'm happy to entertain those. Also, if we can, or if you guys want to make the discussion, totally for that. I have a lot of slides. I'd be happy to go through it. But as you have questions, raise your hand. Don't really want to wait till the end. Probably, about 50 minutes till the hour, so I'll do a formal break to entertain questions before we go into more like a SaaS worldwide approach to analytics. I do have quite a number of industry-specific examples that I could go through if you guys want. So again, like when we take that break, please do feel free to ask, any questions that you want related to the topic. Quick run through. Basically, we'll be talking about what is big data in healthcare, primarily opportunities and challenges when it comes to that, application of big data. As I said, I have quite a number of examples around that. So when it comes to SaaS in healthcare, we do have roughly over 60,000 customer sites. I just put a few of examples up here, including like Cleveland Clinic, Kaiser Permanente, others, but there are really very few healthcare entities where SaaS is not applicable. And folks always ask me, well, gee, what do you do for them? Well, oftentimes these entities purchase our software and they use them with folks like you as employees. So I don't really know necessarily what each one of these customer sites does with our software. But also we are now starting to provide what we call verticalized solutions, meaning specific applications of SaaS to these entities, and I'll go into a little bit more detail what that actually means. Why do we talk even about big data in healthcare? Well, we don't really have to focus too much about the tremendous transformational change in healthcare. Here in the US, that's really top of mind, but when you look globally, this is globally top of mind, has been top of mind. In Europe and Asia, in the US, we have really unbelievable transformational changes. Now, these changes have come along with access to data, as well as access to technology to actually do something with that data. So right now, we're at a very nice junction where we have a business reason to analyze data, we have relatively good data, and we have the technology to drive insights. So right now is an incredible, exciting time to be in analytics, specifically in analytics in healthcare. It's a little bit of an eye shot, but that kind of like just reminds me in terms of what has been the journey over the last 5 years when we are talking about healthcare analytics. It's really around, we all hear the buzzwords about payments, cost, quality, outcomes, and it's truly a journey. And our provider systems are still on their journey, our insurers are on their journey, and SaaS is there to help along the way. So one of the things that when I talk to my customers, usually kind of like what I'm picking up on is that there's a tremendous convergence of, in healthcare specifically, clinical considerations, You know, when you're a hospital, it's readmissions, like, you know, who is being readmitted, why is I readmitted, why do things happen in my hospitals that I don't want to happen, sepsis, infections, etc. We hear buzzwords like population health, but they also start to increasingly blend with business considerations, such as bundled payments, how do providers get paid for their work, network optimization, patient leakage. Well, what is that? It's kind of, you know, how can I predictably make sure that, you know, my patient stays within a network of providers that is close to my system? For two reasons. One, that I can better serve the patient. Two, that if you're a hospital system, that you can capture the revenues that that patient will provide so that you can stay in business. So we have this convergence of business considerations and really clinical considerations, which is a really good thing. So when I think about innovation in analytics, I always look for what is the tie-in to the business case? Why are we doing those analytics? What is it ultimately that we are trying to solve for? Generally, when you try to get funding allocated to things, you do look for things that ultimately impact how your organization runs. This is not always profit-driven, that's oftentimes cost-driven as well. It doesn't have to be that you want to make money. It at times has to be that you want to save money to stay in business, or you want to contain costs so that you can stay in business. Specifically in healthcare, for many hospitals, that is a reality today. It's less about making money, it's really more about staying in business and be able to serve the communities. So Robert Henkel, the CEO of Ascension Healthcare, you know, this is a quote from 2012, and I want to say that quote is still largely true today, is that oftentimes in healthcare, we don't know how to leverage analytics, and oftentimes we don't even know what questions to ask yet. And part of that has to do with the fact that we are still in this transformation in terms of how payments are issued, kind of like what the business model for healthcare really is. So since then, we have actually grouped and have done quite a bit of progress in terms of understanding what are the analytic challenges or opportunities. Roughly, they focus on, you know, I call them the 5 pillars of healthcare. So 4 specific business applications are manage financial risk and incentives, proactively manage quality and outcomes, improve efficiency of care delivery, and increase population health and patient engagement. For me, when we are talking about population health, we are talking about being able to take on risk, taking on payments for the quality of outcome, meaning you keep somebody healthy, versus delivery of a service, meaning, you know, I do something once something bad happens, meaning I start, you know, moving once there's a heart attack or a stroke or some other catastrophic event. When we are talking about population health and patient engagement in the age of, you know, accountable care and healthcare reform, we are talking about receiving payments to avoid bad events, meaning you do things to avoid the heart attack, you do things to avoid the stroke. And that is the fundamental shift in business model that I'm talking about. All of that, of course, is only possible if you have a robust analytic foundation. And, you know, we can have a discussion on what does it actually mean to individual organizations. Does it mean that every organization has to be, you know, has to have analytics as a core competency? Or can organizations be consumers of analytics? And that ultimately will drive quite a bit your career decisions as well in terms of, you know, where do you think you will work? Will you work specifically for an insurer or for a provider, or for an organization that derives insights that is provided back to these providers, insurers, or to pharma? Let's talk a little bit about big data and what it means to you. So with big data, it's been quite a topic for some time, so I just want to go through it relatively quickly. There are lots of definitions of big data. Fundamentally, the definitions that I like is big data is whatever data there is that puts you outside of your comfort zone. So that could be, for some organizations, data that doesn't fit in an Excel sheet anymore. For other organizations, it could be tremendously large data sets that computationally will take, you know, days or sometimes weeks to even compute. The point is, big data doesn't mean that it has to be massively complex. It means it has to exceed the complexity of your ability to deal with that complexity. We have a couple more definitions in terms of, you know, like how folks generally kind of like think about big data. It's volume, velocity, variety, veracity. It basically means the type of data that's coming on you, the type of data sources that you have, the speed at which you are receiving that data, and also the cleanliness of that data, meaning is that data actually useful in my analytic quest? How much data is there? I'm just going to go through it briefly because this is always overwhelming to me. These statistics get outdated the moment you put them on a slide. So just a few years ago, the US was the largest single contributor to global data, period. By 2020, you know, that's going to change. So globally, we are generating data. These days, and this is kind of like a startling statistic, more data per second is generated than there was in the entire internet 15 years ago. And we believe that by 2020, that will be 50 times larger. The interesting piece is only 33% of information could be useful if appropriately tagged and analyzed. What do you think how much data of all that data that is being collected is actually being used for analysis? Any guesses? Like, who thinks it's maybe like 10%? Who think it's more than 10%? Who think it's less than 10%? It's shocking. It's about 1/2 percentage point of the data that is actually being used in analytics. Now, why is that? Well, primarily it's because a lot of the data is in unstructured formats, meaning I don't have really a way to be able to query it. I don't have a way to easily put it into kind of statistical models that make sense in the traditional sense. So when we are talking about big data in healthcare, we are talking about being able to not just get access to the data, but being able to make the data useful, not just for decision making, but actually for the analytics that go into the decision making. What good is all that data? Well, raw data is just organized facts, kind of worthless in and of itself. You know, if all you do is, you utilize about 0.5% of all the data you have available. The rest of it, if you don't make use of it, is worthless to you. Information, well, it's potentially valuable. It's, concepts based on data. It's knowledge. Well, that's what we understand. That's kind of like insights we are starting to get out of that. Wisdom, effective use of knowledge in decision making. Ultimately, the reason why we collect data and analyze is, at least in the context of healthcare, when we talk to organizations, we're talking about disruptive information. This is seen from Moneyball. It's kind of like an old, if anybody talks about big data, you'll always come with the Moneyball. You guys are familiar with Moneyball. It's ultimately how data really transformed, in this case, the business of baseball. Well, within healthcare, we have a similar concept of kind of like Moneyball. We are looking for transformational changes in healthcare. I give you one example right now of a transformational change at an individual level. And while this is a SaaS day, I don't want this to be a SaaS commercial, so I'm going to play you a video clip from Intel.
I was recently diagnosed as being medically boring. Now, this is good news. This is a miracle, really. 25 years ago, I was diagnosed with a rare form of kidney cancer and 2 other diseases, and the prognosis from the doctors was bleak. They're like, you're going to have 1 to 2 years to live at most. You'll never get a kidney transplant. You need to prepare to die. And I started to do that at first until I met another patient who kind of woke me up out of this fog and said, get thy data. I didn't even know what she meant by that, but we went to the library, started doing research on the conditions and the proclamations they had given me, and pretty soon sort of figured out they didn't know anything about me. People 19 didn't get these rare forms of kidney cancer. And I managed from that point forward to be a data-driven, proactive patient, sort of carving out my own path to figure out how I was going to get back to health and wellness. Now, this worked for a couple of decades, and I sort of turned cancer into a chronic condition and managed it almost sort of matter-of-factly, until a few years ago when my kidneys finally failed. And I knew that I was in trouble because the options for chemotherapy and the options for treatment once your kidneys are failed are quite limited. And then I got really lucky. I happened to run into somebody who worked at a company that said, well, why don't we sequence your whole genome? I didn't even know what this meant. I knew Intel had been working with genome companies and universities and cancer labs who were coming to us because they didn't have enough compute to sort of solve the problems that they were doing. But suddenly it was real for me. It took 4 weeks of processing in one of Intel's high-performance compute clusters to sequence my genome, just to get all the DNA lined up and figure out where my mutations were. And then it took another 6 months of FedExing this 5-terabyte whole genome file that it created back and forth from my West Coast doctors to my East Coast doctors to try to make sense of it and figure out what was wrong. Until one day, all my doctors sort of came in and said, we have misdiagnosed you for 25 years. We have put you on countless chemotherapies and radiations and other kinds of treatments, and the cost on you and the healthcare system are all just insurmountable, but we didn't have a way of discovering this before until now. I mean, that's the power of big data. I don't even like the term big data. We ought to call it big discovery, because this big discovery in my life meant all of a sudden I was cured enough to go get a kidney transplant, And 7 months ago, I had that surgery thanks to an Intel employee who donated to me, and now I am sitting here as healthy as anyone. I ran 6 miles this morning, which I haven't done since I was age 19, all thanks largely to big data analytics. Now, Intel.
So there are multiple aspects of why I wanted to play that video clip. Let me go back to presenter mode. There we go. It's kind of like the question is, there were several concepts there. A, big data really had an impact at the individual patient life. The second aspect is of what he described as what big data is. So that clip was posted back in 2013. I want to challenge that what he described as big data back in 2013, for many organizations, or even in terms of kind of like the capacity and capability that analytics companies can provide in terms of the technology you have available to deal with that data. It's not just SaaS, it's other organizations as well, where our efforts have led to the fact that what he describes as big data is not really big data anymore. This is not data that puts us out of our comfort zone. This is data that we can comfortably handle now. But the point is, you have the transition of what used to be big data, meaning uncomfortably big, to now being manageable, but also the impact that data can have at a specific patient level. We'll have a couple of examples, where it's a little less dramatic at the patient level, but very dramatic at the entity level, let it be a hospital system, let it be a payer or a pharmaceutical company. So what good is big data in healthcare? Well, I like that picture. So in healthcare, our chief medical officer, Dr. Graham Hughes, he always tells me that so a physician can usually track about, or a relatively smart person can usually track about no more than 7 data points at any given point in time. Well, I see an awful lot of data points in here, probably more than 7. What I don't see is a patient. There's a patient there. So what we are seeing here, it kind of looks like a storage closet. It's not. That's a NICU. So you see like tremendous amounts of data that is coming at you from multiple sources at multiple speeds, and you need to be able to integrate and make decisions on that data. Another point is when it comes to big data in healthcare, we spent about, I calculated out, 3,600 seconds per year with our healthcare provider. That's about our annual physical if we actually do that. The rest of it we're spending out in the community, spending that in the office with our families. We're spending that in our free time. Well, when it comes to health, how much time you spend with your healthcare provider is really not the key driver or the key determinant of how healthy you are. Ultimately, you have genetic factors, you have the health system, you have environmental factors. All of these factors make up roughly 50% of information that explains why you're healthy or not. A tremendous amount of your health is explained by health behaviors. Well, these type of health behaviors are not really captured in the physician office. These health behaviors are captured out in the community. And that's where we are starting to talk about big data in healthcare, where it talks about being able to make these kind of decisions and derive insights at the individual level that combines genetic data, individual data, environmental and behavior data. So when we're talking about that, the question derives, well, gee, we have all that data, we heard about that data, it's on the news all the time. What's different here? It's kind of like this gold rush for information based on all of that data. And we have plenty of examples where that has really paid off. Here's an example of eBay, who's using analytics at tremendous speed, tremendous insights on a daily basis. It is simply amazing what eBay does with analytics. Talking about Target, you probably heard about that story, but let me just go through it very, very briefly. It's was a predictive algorithm to identify when do I target somebody. We probably all have gotten flyers in the mail or specific emails sent to us that tries to pitch a certain product. Well, Target was getting really, really good at predicting who might actually be pregnant based on the items that you purchase in the store. The downside of that story was they sent an advertisement congratulating somebody that they were pregnant. Well, the folks that they sent that to was, I believe, a 16 or 17-year-old girl who was still living at home, and the parents found out about that pregnancy through that mailing. So it's also the kind of like the danger of what big data does. We can go through it. Zulilo or Amazon. The question is kind of like when you're there and it's the last second before you check out, another ad pops up with an item that you really enjoy having, and you end up buying that. Well, that's big data at work for you. That's targeted information in real time that impacts the business. What is those kind of like, when I kind of took a look at it, what is it about these organizations that can really drive measurable business value out of big data? Generally, it's shared. Ultimately, the biggest difference in practical analytics, I'm going to read that off, may not be in how we analyze or interpret results, but rather how that information is shared and consumed by all of us. In the case of eBay, it's kind of like everybody has access to the information. It's very easy to verify where it comes from. It's enabled data analytic portals and interactive analytic tools available to business leaders, analysts, and scientists alike. So when it comes to analytics, honestly, you don't have to be a PhD statistician and IT programming hybrid in order to derive insights based out of analytics. The second half of my talk, I'm going to show you kind of like the SaaS approach to what that actually means. I grew up as a programmer, and I used to program quite a bit. I do enjoy the modern aspect to our tools, not just our tools, but where we can make use of point-and-click interfaces. I don't have to code everything. We can make use of things that are already baked into our systems, that if I want to run a regression model, I just need to know about the regression model. I don't need to know how to code it. I have systems that tell me what a reasonable model fit might be. Basically, it's aided analytics. So if you want to derive at an organizational level insights out of analytics, it's about enablement. And lastly, transparency. You have to be able to understand, how did these insights, how did these recommendations come about? Where did you make those decisions? It's key, because when you make any decisions, let it be at your executive level or any way through kind of like the decision-making chain, you want to have confidence that your decision is based on truth, or as close to a truth as you can possibly control. So all of these organizations, ultimately, when you look at these examples of big data, shared, enabled, and transparent. So what's different in healthcare? Is it that we need more data? Is it something, why now? And ultimately, now what? So we already talked about kind of like the convergence of data. Is it really that we need more data? Well, we have an awful lot of data. Why now? We have business models that ultimately align with the fact that if you want to stay in business as a healthcare provider, you're going to have to start to be smart about how you deliver care. If you want to stay in business as a health insurer, you're going to have to be smart about how you manage care. If you want to stay healthy as a patient, you now can leverage data in order to make informed decisions. So how hard can it be? Well, some challenges is healthcare. Healthcare is tremendously complex, as I said before. It's kind of like medicine exceeds the inherent limitation of the unaided human mind, meaning when you have all of these data points coming at you in that NICU, you will need to be able to analyze that, and you need tools. Another statistic was interesting. From best practice to common practice takes 14 years, and then it's delivered 60% of the time. 50% of patients don't actually take their drugs as recommended. So we can actually know what lowers blood pressure. We know how to control diabetes, but unless patients actually take their medications as prescribed, you will not get that outcome. It goes back to kind of like the health behavior piece that I showed earlier. So I want to go through some of the challenges. Well, healthcare big data, it encompasses many types of data with varying volume, speed, structural changes. So we are talking about structured data, unstructured data. Roughly 80% of healthcare data is unstructured. Unstructured data means I cannot plug it into a regression model. I cannot do a correlation on it. I have to actually extract the information. I have to be able to structure it, binary variables, 0, 1, male, female, race, gender, you name it. Physician notes. Is a patient actually compliant with medication or not? Does a patient understand the treatment protocol? Do they buy in or not? Well, information like that is actually contained in physician notes. That's unstructured data. I have to be able to get that into an analyzable format, a variable that I can mathematically express. Well, the next piece is, and that's my point here. It's not addressable by normal tools. So in healthcare, we're talking about EMR physician and nurse notes, discharge summaries, home visit notes, history and physicals, radiology reports. So an awful lot of information is stored in images as well. So in order to make use of that data in healthcare, we have to have a way to actually get the data extracted and statistically and ready for statistical analysis. Privacy is a huge concern. So we are talking about all of these other data sources. Remember the kind of like pictures that I showed you in terms of, genetic data and socioeconomic data. So some of the data sources are fine, like airborne, particular, or pollen data. Well, that data is really predictive of your emergency room throughput on asthmatic events. When the air is bad, chances are that asthma patients will have exacerbation of their disease. They will have acute exacerbation of disease and might actually present in the emergency room. If you know that, you can plan for that, you can have staffing levels to be able to deal with that. Social media data. Well, social media data is good. It kind of tells you, do people think my hospital is good? Do people think my health plan is fair? Do people think if I'm a pharmaceutical manufacturer that my drug is actually valued by patients? Then we're talking about like retail, grocery, and restaurant data. Well, why would I care about that? Well, I might care about it. It kind of tells me, are you actually, eating and living healthy? There's a difference between, what is the difference between a good and a bad diabetic? Well, one way is, they can present in the EMR data very similar. So there can be, 40-year-old males, certain weight, certain blood glucose levels, and certain disease history. But there's one fundamental difference. One diabetic might actually really try to be a good diabetic, meaning avoiding the kind of things that will exacerbate the disease, and the second diabetic might not. Well, traditional data sources don't capture that. Non-traditional data sources do give you an idea about that. So the question is, how do we deal with that from a privacy perspective? Let me play you another clip on that.
Pizza Palace, guaranteed hot in 30 minutes or it's free. This is Mary. May I take your order?
Hi, Mary. Yes, I'd like to order.
Is this Mr. Kelly?
Yes?
Thank you for calling again, sir. I share your national identification number.
Yes, I'd like to order.
Is this Mr. Kelly?
Yes?
Thank you for calling again, sir. I share your national identification number as 610-204-999-8-45-54610. Is that correct?
Yes.
Thank you, Mr. Kelly. I see you live at 736 Montrose Court, but you're calling from your cell phone. Are you at home?
I'm just leaving work, but I'm...
Oh, we can deliver to Bob's Auto Supply. That's at 175 Lincoln Avenue, yes?
No, I'm on my way home. How do you know all this stuff?
We just got wired into the system, sir.
Oh, well, I'd like to order a couple of your double meat special pizzas.
Sure thing. There'll be a new $20 charge for those, sir.
What do you mean?
Sir, the system shows me that your medical records indicate that you have high blood pressure and extremely high cholesterol. Luckily, we have a new agreement with your national health care provider that allows us to sell you double meat pies as long as you agree to waive all future claims of liability.
What?
Do you agree, sir? You can sign the form when we deliver, but there is a charge for processing. The total is $67 even.
$67?
Well, that includes the delivery surcharge of $15 to cover the added risk to our driver of traveling through an orange zone.
I live in an orange zone?
Now you do. Looks like there was another robbery on Montrose yesterday. You could save $48 if you ordered our special Sprout Submarine combo and picked it up yourself. Comes with tofu sticks. Those are very tasty, sir. Good value, too.
But I want double meat.
Well, I'm sure you can afford the $67.
So the point is, like, who thinks that that is actually, it's a satirical example, of course, but who thinks that that is not reality? Well, when you go to the Target web page or to Amazon or any other web page, or kind of like the e-marketing pieces that I showed to you, they know exactly that information about you. They know where you live. They have a pretty good idea of what your income level will be. They have a pretty good idea of what your spending habits are. And that's how these things are tailored. Well, within healthcare, it's a similar situation where we don't make use of that data yet. But in terms of like on the healthcare side, that has tremendous privacy considerations. Now, in some aspects of our lives, we have waived those privacy considerations. In healthcare, that is absolutely top of mind. So the privacy considerations actually come in terms of not just getting access to that data, but also how do you actually apply that data in an ethical fashion. Oftentimes when I talk to folks about big data, we see kind of like this nice little puzzle. And they say, well, the biggest piece is more kind of like getting access to the data. Once I have access to the data, I'll be fine. So we're talking, all right, what kind of data do you want? Well, it's kind of like payer claims data, your insurance data, kind of gives a relatively nice history of, where you came from a disease perspective. Talking about provider data, if you have been with the same physician for quite a while, there's actually rich data there. The patient level data down there on the right-hand side, consumer spending and all of that data, all of that stuff is ultimately available. And folks usually present it in a nice little kind of like pattern. And when it comes to certain businesses like retail or other organizations, that actually fits together quite nicely. In healthcare, picture looks a little bit more like that. We don't have unique patient identifiers. So we don't have kind of like, if you guys, on the analytics side, you merge different data sets together, well, you need to have a merge key. Well, we don't have a merge key in healthcare. We don't have a merge key within an insurance plan. We don't really have a good merge key oftentimes on the provider side. So that aggregation, even if I had access to all the data pieces, I don't necessarily know how to put those data pieces together. The second piece is, when we're talking about Amazon or E-Trade or Target, we are talking about organizations that are at the cutting edge of technology. Well, in healthcare, you are not really on the cutting edge of technology. In healthcare, the core competency is not IT. The core competency is taking care of people. And the business model wasn't there to focus on IT. The business model was there on practicing medicine and doing your procedures and delivering healthcare. Well, these days, if you want to take on patient-level risk, if you want to have a business model where you want to get paid on avoiding a heart attack and stroke and not on treating the heart attack and stroke, you do have to also have tremendous IT capabilities. Big challenge in healthcare. The next piece is, well, what if we integrate all of the data? You guys have heard about the 80-20 rule, about 80% of the time you do data prep, 20% analysis. Well, when it comes to big data, it's not 80-20, it's 95-5 at best. It means with all of that massive amount of data, there comes in a massive amount of ETL, extract, transform, and load, which really taxes that's tremendously taxing. You have to have tremendous human resources internally in your organizations in order to actually get that data ready for analytics. So we want to get back to 80-20, and that's one of the things that we at SAS really focus on. When you talk about big data, how do we actually spend more time analyzing the data than we spend on managing and getting the data ready? Next challenge, big data requires performance. Remember the Intel guy with sequencing his genome? Well, when you want to do analysis on big data, and you guys know that, you have to have tremendous speed and performance. You have an ability to actually see the data, analyze the data in near real time if you can to make your decisions. And I know that our visual analytics demo will likely show you some of that. Let's assume you have solved the data problem. Let's say you have it all. Well, what do you do now? Do you know how to actually do cutting-edge statistical analysis on that data? Do you want to program all that? Do you have enough folks who understand the business issues, understand statistics, and can program? So one of the things that's really when it comes to big data, you have to have an ability to actually extract information out of big data. And again, I'll show you in a little bit on the second piece in terms of how we at SAS at least see that challenge and how we are trying to address that challenge to enable a broader set of stakeholders to be part of the data discovery or insights discovery path. Lastly, when it comes to big data or getting value out of big data in healthcare organizations, it requires a level of organizational alignment that we haven't seen before. So academically, we know, okay, Christian should lose weight and, probably exercise a little bit more, take medication more regularly, etc. But in terms of identifying that, having my physician recognize that, being able to surface my data to my physician so that he actually sees that in some kind of prompt, have somebody work with me on it, and for that to be something that a business or like an organization actually wants to enable, meaning they can extract a return on investment for intervening. And return on investment, I don't just mean monetarily. I mean being able to take an action and have the desired outcome. In my case, it might be actually go to the gym and lose weight. Doesn't always have to be monetary. But it requires organizational alignments that we really challenge still in healthcare between clinicians, IT, business leadership, and caregivers. So I have outlined ultimately 10 big challenges, when it comes to big data in healthcare. And these challenges are real. And we are working with these challenges and with organizations every single day on the insurer side, on the provider side, on the pharma side. So it's not really overwhelming, but here reside your opportunities in terms of, what can you provide to overcome these challenges? what organizations like SAS will do, will provide an awful lot of tools and technology to overcome those challenges. What you can focus on is how do you apply those tools and technology to actually solve business issues and overcome these challenges. One of the ways that I generally think about, about SAS, and I'll go into more detail on this a little bit, is really don't think of it as just a program query prompt language, typing in code, hitting enter and something happens. SAS is ultimately a platform. Or think of analytics if you don't, take the SAS label off. Think of analytics as a platform that starts with data governance, meaning you have to be able to, A, identify the data and integrate the data. And you have to do it in such a manner that it's predictable and scalable, meaning you don't just want to do it as an academic exercise, meaning I can show in principle that it can be done, but you want to do it in such a manner that as the data comes in, you can do it within a time frame that is necessary to facilitate analytics and be able to take action. The next piece up is, so once you have the data challenge, is enabling ultimately insights around analytics, decision management, business intelligence, combining that with knowledge, clinical knowledge. So when I'm thinking, for example, about hospital readmissions, well, I can know data really well, I can know statistics really well. But one thing I don't necessarily know is when I look at my data, let's say I look at insurance claims data, how do I identify that somebody's actually a diabetic? There is no diabetes flag in the data. What is in there is that somebody was in a hospital. There may have been complications that are associated with diabetes. You might see in your insurance data streams that somebody is on, a medication associated with diabetes. That's kind of the knowledge piece. You got to know how to actually translate that data into something meaningful. So the more data sources you have, the more complicated it gets. How do you actually pull together the various data elements and collapse them down into meaningful, data entities, such as I see somebody was in the hospital, I see somebody takes a medication, I see somebody sees a physician from time to time on a related topic. Therefore, that person is a diabetic or an asthmatic or generally healthy. Well, that's kind of like a knowledge layer in there that cannot just be solved by knowing the data or knowing how to program. It can be solved by inserting those kind of knowledge pieces and combine them with data in a meaningful way. So what I'm talking about here is, of course, those healthcare ontologies. What is the set of codes that defines the conditions that I'm interested in? Well, I want to be able to have it in my analytics process that I can apply that knowledge to the data and now have a discrete or a concrete analytics-ready data points that I can actually do something with. And then I want to have the tools to be able to facilitate my analytics. Data models, algorithms, I call them here VAVS dashboards. It's ultimately the final step of how do you actually surface that insight? How do you touch it? So when I think about analytics in healthcare, oftentimes you're talking about technologies. We're talking about all these data streams. What I'm really talking about is kind of like specific issues that we actually want to solve. So it's like patient cohort analytics, meaning, what is the common characteristics of a set of patients and what defines how those patients progress through their healthcare journey? Hospital-acquired conditions. What are the predictors for infection or, for other things that happen in the hospital? Readmissions analytics. Ultimately, what are the predictors of somebody coming back to the hospital? These kind of things I don't always want to do from scratch. I want to be able to address those topics via analytics, but it's really via consumable analytics. So think of it as an app. So the way that I think about all the technology, it's kind of your operating system, kind of like an Apple iPhone. And the app is the specific business applications that you're trying to solve for, where you're standardizing around it so you have at scale, so that you know what your readmissions rate are and what are driving that, how your patients are progressing, through their various disease stages, et cetera. So that is one of the proposals that we have at SAS in terms of how do you deal with big data, how do you do analytics at scale. It's not just about the technology, but it's about how you combine that technology in a meaningful ways that you come up with a concept of what I call kind of like an app. And what I call that kind of software. I call that verticalized software. And we'll talk a little bit more. Some examples. I kind of want to stop here and basically, open it up for questions for a little while before we kind of go into more kind of like SaaS analytics. But I kind of wanted to prompt kind of like some specific examples of how do you leverage the data to answer specific problems. I can tell you, so for example, what we have, some examples are ours, other examples I've borrowed, is the FDA identifying adverse events for drugs in real populations. So as you know, when a clinical trial is being conducted, generally, you're talking about like a 12-week period during which you administer a drug and you measure the effect of that drug, including kind of like adverse events. Well, once that drug is in the real world, the FDA actually has an interest to see, is that drug actually safe? And there are a lot of reporting systems out there. So one of the things that we have done is work with the FDA to design a system that is largely based on text mining, basically converting unstructured data into structured data, to go through all the various reporting systems that are out there that might actually have information whether or not a drug is safe or not. And that could be, I took drug XYZ and now my stomach hurts, or I have a headache. And we are applying technology such as text mining to go through massive amounts of data to derive those insights. Again, you're talking about large data, lots of data sources, and you have to have technology that goes beyond, fingers on a keyboard programming in order to derive those insights. Another example on the health insurance side, and this was really a big topic last year, it still is a big topic this year, is with healthcare reform, insurers now have an ability to actually insure previously uninsured populations. Well, an insurer has to set insurance rates, right? Like, what do I actually need to charge in order to, stay financially viable? Well, that's really tough to do if you actually don't have longitudinal record on the individual patients that you're trying to underwrite. So again, that's one of those cases where the combination of multiple data sources for predictive analytics allowed some insurers to actually get insights to be able to predict the risks that they took on for previously uninsured populations. And you see that issue, if you follow the literature, not the literature, but just the news these days. Some insurers make a lot of money. Others insurers can lose a lot of money. And usually that difference is in your ability to predict out what will be your costs. Well, with the populations that you haven't covered before, you don't know what necessarily your cost is. You don't know what the prevalence of diseases in that population. You don't know how they progress through their healthcare journey. So again, predictive analytics allows to ingest massive amounts of data and to basically simulate out what might be healthcare expenditures for these populations. So this is a global trigger tool that we developed for a hospital system. We deployed it in Europe. And what that system does, traditionally in a hospital, they want to actually measure the incidence of bad things that happen to patients, such as hospital-acquired infections or adverse reactions to drugs or errors that might happen. So traditionally, the way that happens is you take a random sample of shards, you review them, and you identify what is your error rate, or do you have errors, and you then try to mitigate that. So one of the systems that we put together was to basically mine the various information systems that you have, create a set of business rules, stream that data against those business rules, and flag up the specific cases that should be followed up. So we turned the labor effort from basically manually extracting information and spending most of the effort on gathering the information to now being able to automate that, and you spend the human time, the nurses and the physicians' time, on specifically reviewing the trouble cases instead of finding the trouble cases. Huge efficiencies. I'm going to skip through a couple. Here's a good one. I keep coming back to diabetes because population health is kind of like on a big topic. Diabetes is one of the biggest diseases, big cost drivers in the healthcare system. So when we are talking about that, this is kind of like really big for health systems, that's really big for employers, it's really big for pharmaceutical companies, it's really big for insurers. When we are talking now about truly kind of like having business models that are driven on avoiding bad things. So the things that we can now kind of predict out with the data sources that I kind of like outlined earlier, the claims data, the EMR data, the personal data, are things that who is at risk for short-term complications, who is at risk for long-term complications, who is uncontrolled diabetic, and some of these other things. And what can I do with that? Well, traditionally, if I don't have that information, I have to have an intervention that basically, I do want to intervene with the entire population. But in order to do it financially in such a viable method that I can actually be able to say, I spent money and I got a meaningful return for my money, meaning my patient stayed healthy or I've avoided very costly complications, I want to be very targeted in how I do my interventions. So I take Synthroid every day. I've done that for 20 years. The best way to take Synthroid is in the morning on an empty stomach with a glass of water and you don't eat for 1 hour. So when I think about it, if you really want to ensure that every patient actually does that, what's the best way? Well, have a nurse come to my home, ring the doorbell, put some medication in front of me, sit there for half an hour and make sure that I don't eat. Well, it's tremendously costly. So now we're talking about different things like, okay, my physician talks to me, they educate me. I might get a text message that reminds me to take my medication. I might have lab draws done, or, you know, there are lots of different ways to approach that. So we are looking for kind of like what is the best surrogate of that high-touch, very costly intervention to get me to actually comply with my treatment. So that's where analytics comes in, where we can actually identify the right intervention for the right patient, meaning if a patient is inherently fairly compliant, I probably don't want to send a nurse to their home. There's no benefit to that, meaning that patient is already doing what I want them to do. By the way, that patient is also the most likely patient to enroll in that nurse visit program because they actually really want to follow through on the recommendation. You have a different patient where a text message is enough, you have a different patient where a doctor visit is enough, and then you have those patients that really need to have the high touch. Well, what we want to be able to do is leverage data and analytics to identify those patients that really need a heavy intervention, identify those patients that really don't need a heavy intervention, and make sure that we allocate our resources appropriately. In population health, what we have seen so far is that we have taken a one-size-fits-all approach, meaning I give too much to the folks that don't need it, and I give too little to the folks that really need it, meaning I don't really help anybody appropriately, and oftentimes population health initiatives have failed for that reason. Well, when it comes to big data, we now have the tools to be able to be very targeted and at least be smarter on allocating our interventions. That's one specific example. You can translate that through hospital readmissions, et cetera. Within healthcare, I call that I want to predict risk off, and you fill in what that risk off is. Risk of disease progression, risk of a readmission, risk of an acute event. These are all risk predictions. What all these various data sources allow me to do is to ultimately do a better job at risk prediction. Risk for cancer, risk for readmission, risk for disease, et cetera. Another example is using analytics, for example, for preventing fraud. This is one of the things that we do quite a bit. It's really important for healthcare providers as well as health insurers. Well, what does fraud mean? Well, there are instances where you see a provider now billing for multiple surgeries in a day on the same patient, where you see multiple family members in treatment simultaneously, et cetera. So these are instances of fraud. That's tremendous waste in the healthcare system. When we talk about high cost of healthcare, some of that is fraud. So we can devise analytic algorithms to ultimately go against that data to identify those anomalies and follow up on that. Very credible example, a lot of health insurers are running ultimately these fraud prevention analytics at scale. It's real business for them. I mean, those things really save millions of dollars. And the way that you do that, again, is to run against multiple data sources and automate as much as possible and apply the best statistical techniques. So I want to open it up for questions at this point. All right, if you don't have questions, I'll have questions. Yeah?
Well, no one else is going to. I've got a great one on that. So recently I heard a report about how Pennsylvania is looking to optimize their incarceration and probation rates among the prisoners, the prison population. They want to save money and they want to make sure they're incarcerating the right people. One of the controversies in this bill that's trying to pass, though, is the racial aspects and economic aspects of the prison populations. That informs the data, unfortunately, but I'm wondering if you think that if we take out those factors, would that normalize the prison population and eventually remove those biases? Do you think that's a possibility? If you took out the racial and economic factors in the analysis and did everything else, age, whatever, what type of crime what was committed,
We do, thank you. We do have an awful lot of data, so we are working with pharma companies on ultimately how do you pool all the various data sources, primarily claims data, EMR data, et cetera, to facilitate what we call almost like predictive analytics of a clinical trial. I want to call it like in silico modeling of a clinical trial, meaning that I'm moving away from using the clinical trial to identify the hypothesis, but using the clinical trial to validate the hypothesis. Meaning we do know the correlation between biomarkers and outcomes, so we can discover that in the various data assets that that I have alluded to. I can see that if I have a patient with a certain baseline characteristics, I can now fairly accurately model out what is their disease progression, meaning what type of events do I expect to see. So when I have that within a clinical trial, if I know the impact on my biomarker, like HbA1c levels or blood pressure level, I don't know that I necessarily have to run a clinical trial to see how that drug ultimately impacts outcomes, because I do know how that variation in the biomarker affects outcomes. To what degree the FDA is moving towards providing approval based on modeled outcomes versus observed outcomes, that's a really interesting question. One of the reasons why we have quite a bit of emergence of, we call that late phase trials or real world trials, is exactly to that point, is to actually validate in real world populations that drugs are effective. So with a lot of drugs, they will run trials in the real world where you don't have the randomization event. You ultimately are seeing that a patient is on a medication and that patient is tracked via various data systems with their consent, so that you collect what is called real world data. And that data is ultimately used to justify the efficacy and safety profiles of these products in the real world. I can give you one example. Large manufacturer, since you are filming, I don't want to name the name, but they developed a drug, I believe it was for multiple sclerosis, and they ran a clinical trial in a patient population, that was actually reasonable. And they had the efficacy and safety profile, and they tried to get that approved in a country in Europe, and the country said, no, I'm not going to approve that drug. It was a very expensive drug. And the rationale was that the clinical trial was run in a patient population that wasn't relevant to that health system. Meaning kind of like the patient characteristics, the age and disease the demographics as well as the disease characteristics wasn't what that insurer traditionally saw. They said, I don't actually believe the data that you have shown me, I don't believe that you will generate value for my specific patient population. Specific example there is, had that manufacturer done a better job understanding what the actual patient population in that country was, they could have designed their clinical trial to generate the evidence that was needed to get reimbursement and approval. Yes. Yeah. Yeah. So we do see that everybody's talking about Hadoop. Everybody's working on their Hadoop strategy. We do see that quite a small fraction of folks who have Hadoop strategy period are implementing that strategy. In healthcare specifically, that's still emerging. A lot of our provider systems are still implementing the Epic and Cerner implementations. So they are not necessarily at a place where they are really thinking about how do you get the data ready for analysis. So there's an awful lot of kind of like business intelligent reporting, meaning dashboarding, capturing of events, not predictive analytics. So where the Hadoop strategy comes in, where some of the largest health systems are looking at that, we're working with some of them, where we do see that emergence, and it's primarily due to a factor of cost, to be honest. Hadoop is a very efficient way to store an awful lot of information, and it works very well with, for example, like SAS has invested quite a bit in order to actually have that data feed into the SAS systems, or the SAS systems being able to access the data via Hadoop in a very efficient manner, so that allows us to actually run analytics at the lowest cost possible. Analytics is not cheap. But with Hadoop, it can be less expensive than in other ways. Also for healthcare, I believe that the Hadoop strategy might be a nice one because it doesn't require me to pool all the data into one large analytic data warehouse that allows me to create data lakes. So as long as I can focus a lot of my efforts on the translation data layers, the ontologies, et cetera, the data models that allow me to pull data on demand when I need it, lift that data up into memory, meaning I can actually compute in real time. I don't have the latency or the compute latency that I used to have. So that's where Hadoop really comes in. It allows me to deal with that massive amounts of data and takes that latency out. So healthcare organizations that see that as a business problem or on that path towards that business problem, I do see them taking a very close look at that. Yes. Yes.
You mentioned something Alex, about insight being the ultimate outcome
Right.
that organizations are trying to get from analytics. That statistical tools and information technologies are there to make that happen. What can healthcare organizations, as well as other organizations, do to prepare themselves to be receptive to the insights that come from big data?
Well, it's really twofold. It's an ability to actually act on that information, not just a willingness, but the ability to act on the insights that you might actually be driving in terms of, there's an awful lot of change management that has to happen in healthcare to actually change processes, even fairly proven processes. So there are some organizations that are tremendously good at that. So, for example, healthcare organizations that have aggregated a lot of providers under one umbrella and has relatively global policies and ability to actually get not just providers, but kind of like influence workflow in such a manner that it's predictably really done. Those are organizations that are more easily geared towards being able to capitalize on those insights. So that's one piece. The second piece is the ability to actually generate kind of like the data lakes that we talked about, to do analytics that is meaningful at the individual like facility level even, because we did have quite a bit of healthcare kind of like aggregation. Health systems are buying each other up, et cetera. So you have so many different source systems still that a lot of the work that is being done right now is still on the data management, data integration side. As health providers progressing and maturing through that, you will be able to derive insights, and you will be able to basically make decisions on analytics, or at least have analytics inform kind of like business decisions in terms of, what are meaningful workflows, et cetera, and not just be able to make that recommendation, but also be able to measure the impact. So ultimately, are folks actually following through what you want to happen? Is what you want to happen actually influencing outcomes the manner that you think it does? So when it comes to being able to take advantage of the insights, it's really being able to A, understand them, make sure that they are meaningful and credible to your organizations, meaning they're actually based on the data that is meaningful to you. Thirdly, you have to have an ability to influence workflow, et cetera, based on these insights. Fourth, you have to be able to see how those workflows actually impact within your organizations the outcomes that you believe a priori that it should actually impact, and be able to take that. So it's a relatively complex journey, to be honest, especially in very complex organizations like healthcare. We are not talking about Amazon or Target or retail, where you have an awful lot of control over the operations and you have a high degree of predictability. If I get a marketing campaign wrong, if I work at Target or at Amazon, I might lose some money. If I get a treatment flow wrong, somebody might die. So kind of like the impact on the business in healthcare is kind of like, it can be a 0-1 discrete event, meaning, I'm saving lives or I'm not. So that is another consideration in healthcare to be taken into account, especially on the provider side. Yes? Yeah, so we pay a lot of attention to. So the question was, how does SaaS ultimately keep data protected, and do we focus on data security? I can tell you that not just in healthcare, but traditionally SaaS is a tremendously secure system. For many, many years, even before healthcare kind of became on the forefront, we have dealt with very, very sensitive financial data, tax data, IAS data, CMS data. So data security is tremendously close to us, and we are applying that now in healthcare. So one of the ways that we do it is, we are fully capable of hosting data, meaning we can take very sensitive patient-level data and keep it very secure. Or we enable organizations to host their own data, meaning you do analytics on-premise, not within your organization, not at SaaS. And we have a tremendous focus on security. And one second. So also we're working with healthcare systems where all the tracking of login information, who gets what information, making sure that folks only with the right access have access to the data. We have systems in place that allow us to actually scan how the data is being used to find abnormalities in terms of, is somebody downloading too much? Are there too many queries? What is abnormal about kind of like the transactions that we are seeing? So we have tremendous tools and solutions around that space to A, keep data secure, and B, actually detect when that data is under attack. So it's two aspects. One is keep it secure, and the second piece is being able to actually know when you're under attack, when is somebody trying to do something that shouldn't happen. It's a big, big initiative at SaaS.
Take this opportunity for Chris to transition into the next phase of his talk, discussing SaaS data analytics worldwide and some of the tools from SaaS and their approach to analytics to make some of the things that he's talking about in his healthcare application possible.
Yep, happy to. So I was actually thinking about flipping the talk, but I didn't want to kind of like impact the agenda too much. So in terms of like, who is SaaS? Well, SaaS as a company, we are not just a healthcare analytics company. You know that. We have been around for nearly 40 years, headquartered in Cary, so we are a US-based company. And, but we do have offices just all the way around the globe. Right now, we are organized across our horizontal solutions, meaning like a lot of the solutions that you have access to, visual analytics, our modernized tools, enterprise miner, the programming language, base SaaS, et cetera, our data management tools. So we have all of that horizontal, but we also focus in the verticals, meaning in the specific industries. So we have our finance division, our education division, retail division, manufacturing division, healthcare division. So we have multiples of those. I can tell you now with pride that healthcare right now is our fastest growing division, so I like that. But SaaS is taking globally an approach to very specific industries. And we are taking the approach of leveraging our horizontal capabilities within those verticals. So some of the things that you see within SaaS is that we are actually actively pursuing things that are really meaningful within the specific vertical. So what I called like an app-based approach, where SaaS is the operating system, we have all the tools, but we are also there to ultimately help our customers to derive those insights via app. A lot of you guys will be working, within organizations where you're ultimately working within the operating system, but you might also be building some of your own, what I call like analytic applications. So SaaS globally, we service all industries, have serviced all industries, and have that horizontal as well as vertical approach. These days we are hiring, not just really, smart programmers, but we're also focusing on bringing in industry experts. It's not so much that we are turning into a consulting organization at all, but it's being able so that we can really connect with our customers on how analytics is applied in their organizations from a customer perspective. Because the biggest deal really is when you're talking about big data, or it doesn't even have to be about big data, but we have now matured analytically to the point where it's really not about data integration. It's really not about, being able to run a model. It's really not about being able to build a dashboard, but it's being able to predictably solve a business problem based on the data that we have within a timely fashion. So we really focus on working with industry consultants alongside with technical consultants to really identify how to best solve the industry challenges. A couple trends in terms of complex business problems drive analytic innovation. Well, that has been true for quite some time. I mean, when I think back to even Henry Ford, when he realized that there's a better way to put together a car, ultimately he took the data that was available to him, which was big data at the time, analyzed it and identified, the concept of, well, all the efficiencies that you can drive in the manufacturing process. So again, when you see complex business problems drive analytic innovation, that is nothing novel. That has always been around. When I think about like Galileo looking at the stars, he probably saw big data, when you look up there. Well, with the telescopes, that big data all of a sudden became manageable and you can derive insights out of that. Similarly, when I think about kind of like these challenges, they have always been there. Big data is nothing new. Complex business issues is nothing new. It looks complex until you solve it and all of a sudden it becomes easy. and then you go to the next complexity. So what we have today, we have data abundance. Data really isn't the challenge. Well, data is always a challenge as you try to get more complexity, but we have an awful lot of data in order to solve an awful lot of business problems. Next piece is computers getting cheap. We are not talking about mainframes, that take up the size of this entire room. We can do an awful lot of compute power with a simple laptop these days. We can do an awful lot of compute power with an iPhone these days. We have to maximize value and engagement of high-end human capital. Actually, that's probably one of the biggest challenges that I see when it comes to worldwide analytics, is actually having folks who understand both the business issues and have the technical and data acumen to really tackle that. And those are really the areas where we are addressing that. Security is one of them, How do you actually leverage systems versus people in order to do a lot of the monitoring, for example, of the security threats that you have, or to automate some of the analytics that you can facilitate. And ultimately having an enterprise approach to data and analytics. And I'll go into a little bit more on that piece. The era of doing all of your analytics on your PC desktop is rapidly moving away. Some industries that has completely gone away, other industries, including healthcare, we're working on making that go away. It's truly about an enterprise approach to data. If you want to have insights at an enterprise level, you have to have access to that data at an enterprise level. If you want to drive analytics in terms of the kind of like compute powers that I'm describing, you do have to do that at an enterprise level. That doesn't work anymore, it's individual desktop level. Why analytics? Well, it's really moving from hindsight to foresight. And ultimately, it's kind of like on the lower end, if you look at it on the maturity curve. And we have solutions to each one of these pieces, is kind of like questions of what, so what if, and what now. And it really depends on the organizations that you're working with in terms of where they are on that analytic maturity curve, but everybody wants to get to the what now. So predictive analytics in terms of really being able to drive decision making. Decision making means you have to be able to understand trade-offs. Trade-off means I have to be able to do my what if analysis, etc. I cannot just look in my rearview mirror, I have to be able to predict out what's coming. A different way of looking at it is kind of like, how do we move on what happens to what's the best that could happen? Not just what will happen, but what is the best that could happen. So we really focus on the optimization problems, like the multi-constraint optimization problems. How do I do the right thing for the right target at the right time? These are multi-constraint issues, and you can translate them to healthcare as well as to any other vertical, let it be energy, let it be retail, let it be manufacturing, let it be healthcare. I'll give you one example. On the energy side, for example, when a drill bit breaks in an oil well, that oil well can go down for quite some time, and it'll cost millions of dollars. So one of the things that we are doing, for example, is we are streaming all of that data that is captured by that drill well, and we can actually now identify when is that drill bit most likely to break. So there are two issues here. The drill bit is really expensive. Moving the drill bit is really expensive. Having people on hand who can change it out is really expensive. So how do we know when to get the darn thing to the place when it's most likely to break with the right people to actually change it before it breaks? That's a multi-constraint optimization problem. How do I know within healthcare now when I discharge a patient, how do I know what level of help does that patient need in order to make sure that they stay healthy and don't have to come back to the hospital? Well, again, that's a multi-constraint optimization problem. And that's where, the predictive analytics and where SAS really excels. It's kind of like, give us the hard problems. Ultimately, when I think about data and analytics, it's all about being able to make better decisions. So it's not just about visualize and discover, but it's all about implement. And that's kind of like you had the question earlier in terms of, how do organizations actually make, analytics part of their decision-making process. And that's kind of a big deal. A lot of organizations are fairly good at the visualization and the discovery piece, not necessarily that good. And folks are getting really better at that, and we're helping with that, is in terms of how do I actually implement the insights that I'm getting? How do I automate and monitor and continue to optimize around that? The next piece is analytics scales and place automation when feasible. It's kind of an eye chart. But this is kind of just a subset of the kind of things that you want to do or you may think about doing when you do analytics. you know, as I said, like when I graduated, I worked in a large think tank, and I had fingers on a keyboard, and I did a lot of these things, and I programmed them up. You can program that up in SAS, you can program it up in R, you can program it in Python, lots of other ways how to program it. It really takes time. So one of the things that we really focus on is how do we actually capture some of these processes and make them scalable? Meaning that a smart driven person can do these things once. How do I do that now in such a manner that I can do it repeatably, meaning I can control quality and enable more folks to actually be able to do that specific task, meaning I'm capturing both the process on the quality side as well as the process on the knowledge side, so that you don't have to be an expert on programming up text parsing routines, but you can still use tools in order to be very effective at text mining in order to translate that unstructured data into structured data, just as one example. So what we really focus on is to move away from programming, doing the programming for you, and packaging those things up as discrete software. Why do we do that? Well, with speed, there's business value. I mean, you have a tremendous amount of lost time. I like to give the example in the pharmaceutical industry, you know, and simply because it kind of like is a nice way to kind of like articulate the economic value proposition of analytics. So when you think about a blockbuster drug is $1 billion per year. Well, if you divide $1 billion by 365 days, I don't know, you're probably better at maths than I am, but it's a couple $1 million a day that you're losing. So we had the question around like clinical trial design and kind of like how do you model out outcomes, and pharma companies really spent an awful lot of time on that. And here's traditionally how it kind of works. Smart guys sit around the room and they say, you know what, I think my drug works in diabetes. Well, what type of patient population do I want? Well, let's take a diabetic, 35 to 50 years of age in one cohort, you know, and 50 to 75 in another cohort. And let's say, you know, they have a certain disease stage, you know, they have comorbidities, they also have heart disease. How many patients do I have? How quickly can I enroll? All right, I post that to my analytics teams, they go off, they take that data, you know, that is available, and they crank it. Usually takes about 2 weeks, and they come back. And folks sit around the table and say, wow, that's really cool. Now, unfortunately, I just weeded out 95% of my addressable patient population. So I probably don't want to run that clinical trial. All right, let's adjust some of these parameters. Analytics team goes off, 2 weeks later, you get back together. You've just spent a month. So the one thing that we are working on is, well, how do we get that month shorter? So that's where SaaS technology comes in around data integration, the enterprise approach in order, meaning having all that data accessible, being able to lift that data in memory, having the data translation in there, meaning that I'm not dealing with raw data, but I'm dealing with data that has been meaningfully prepared to enable analytics, so that I can now sit with my decision maker. What used to take a month, I can now sit at the table and we can say, what does my patient code look like? I can click on it and I can see it. So I'm taking a month process or a 2 week process now into, you know, 5 minutes or less. All right, you get your output. Let's change it one more time. What does it look like? You're taking another 2 week process down into another couple, into minutes. And hopefully, you know, our demo on visual analytics can show some of the speed on large data. It's rather tremendous in terms of what you can do. But what you have just done is you have taken out a month out of the drug development process. So when you think about it, you know, let's say $3 million a day by a month, I mean, we're talking close to $100 million in value generated. Now, that's one extreme example. But when we are talking about analytics and being able to package all of these things up in a scalable approach, you're starting to talk real business impact in a predictable fashion. If you have clean data and with transparency, you can show how you actually make that recommendation, and you can measure the impact of your specific solution on the outcomes that you want to drive. The next piece is, and this kind of like, you know, SaaS is, you know, depending on who you ask, it's one of the number, you know, 1 or 2 employers in the US and the world. You hear that all the time. We have great quality of life. Got a great gym, you know, swimming pool, all on site, cafeteria is amazing, you know, I can eat sushi downstairs in my building. It's just rather nice. One of the hardest things that is actually in my job is finding the right people, finding even people who can work at SaaS or want to work at SaaS. And the reason being is because all of the things that I mentioned before in terms of, you know, big data and analytics and efficiencies, well, that's just not me talking, that's all of our clients doing. And our clients are looking for folks like you and folks like me to help them drive insights out of that data. So we are having a really hard time actually finding folks who can work for us? Well, one of the things that you can do is if you have a really hard time finding the right folks is, and that's where we're really stepping in, that's where I'm talking about, emphasize software over programming. It's not to replace FTEs. It's being able to do analytics when I cannot hire enough FTE full-time equivalent, when I cannot hire enough people. We do have a shortage, and that shortage is not going away anytime soon, so we recognize that. So the SaaS global approach that we are taking is to package as much as we can into discrete software events, both at the horizontal level, meaning we can apply it across industries, as well as within the vertical, meaning very specific analytics-oriented solutions within our industries. What does that mean? Well, it means that we enable collaborative decision-making, powerful predictive analytics that doesn't require coding. I like coding, but I don't want to have to do coding. Develop and run models faster, share insights across platforms. Develop and run models faster. Let me give you another example. We worked with a local clinic, here actually local to you guys, and they wanted to build a model that predicted the length of stay for patients with scheduled procedures. Think about knee and hip replacements, fairly standard. So they wanted to be able to see, like what patient profile should I schedule early in the week, that might actually be discharged fairly, that might actually be in the hospital for a couple of days versus what patient profile can I schedule, let's say on a Thursday, and they're still discharged on a Friday. Why do I want to do that? Well, I don't do surgeries on Saturday and Sunday. I don't want to have to pay for the staffing. The patient doesn't want to be there when there's nothing happening. So I want to build those kind of models, one specific application. So we installed one of our high-performance engines. It wasn't Hadoop, but we installed one of our high-performance engines in one of our tools. And I believe, I don't like to drop name tools, but we used Enterprise Miner on top of the data. So my client came to me and I asked him, I was like, well, so why are you smiling? You look pretty happy. I was like, well, I was able to build a very predictive model. I said, how long did it take you? He said, well, it took me about a day. I was like, all right, so why are you smiling? And he was like, well, I was able to read in the data. I did it myself. We are point and click. Ultimately, you see some of that. I was able to build the model. He could run it, and he got a highly predictive model, and they're using that in terms of, their scheduling of, again, like scheduled surgeries, knees and hips. So where you have a lot of influence over when do you bring the patient in. I said, all right. So why are you smiling? I was like, well, I was able to get my predictive model in a day. I was like, well, that's good. He said, well, then I brought in my key programmer, my lead programmer, really smart guy, knows the industry, knows how to program multiple languages. Again, this isn't what SaaS. And he asked him, was like, well, I want you to rebuild that model. He said, I don't want to rebuild that model. I was like, no, I want you to rebuild that model. I don't want to rebuild it. Why not? He said, well, it will take me 3 months to rebuild that model within our systems. I was like, all right. You're still smiling. Why are you still smiling? All right, so you got it down from 3 months down to a day. You're still smiling. He said, well, the model that we ended up with was actually not a model that our lead statistician would have ever specified. And I was like, why? Your lead statistician is incredibly smart. It's like, because there's so many permutations in terms of how you can run models, there was simply ones that they wouldn't have specified. So the reason why he was smiling was because he was able to get an insight in a day. He was able to do it instead of having to leverage very precious resources that are working on other projects. And he was able to get an insight that was on a predictably higher quality than he would have otherwise received. He was still smiling. I said, why? Okay, what else? He said, well, we looked at the codes that your program actually generated because Enterprise Miner can review the code. He said that was way more efficient than we could have written. And by the way, if we would have written it ourselves, I wouldn't have really had a way to quality control that code. So when we are talking about coding up all of these things via software, what our clients are getting is predictable quality, speed, insights, and they can leverage a broader subset of their employee population who can now perform analytics or be engaged in the analytic process. So for us globally, that's a really, really big deal. So the next piece on the software is really, so what does it mean? Well, when you think of SaaS, so oftentimes I meet with clients, and clients still think of SaaS oftentimes as kind of like being a programming language. We are not. We have over 240 skewed products now, meaning these are the type of products that come kind of like off the shelf. So we are tremendously broad company in our application of analytics to the industry. What we really enable is kind of like within that context, being able to serve up these insights within healthcare, clinical considerations and business considerations. In other kind of industries, you see different conversions of kind of like the kind of things that you can do if you have good data, analytic scale and capacity, as well as an ability to ultimately act on those insights. Some of the challenges that we are addressing via our software, and I already talked about it, is we queried about 1,000 organizations in terms of what are some of the obstacles to analytics. Highest one was data quality and integrity and consistency, having access to the right data, departmental silos, meaning one department has one kind of data, another department has another kind of data, and I don't really have any systems to bring those together. Folks who don't know actually how to make decisions on analytics, and lack of appropriate analytic staff. I mean, for you guys who are students here, you will like that message. For you guys who are employers here, probably not so much. But as we're saying, even for us, we have a tremendously hard time hiring kind of like the folks with the profile and the desire to work for us. So when I talk to healthcare providers, and I'm kind of going back to that kind of like, what are the specific challenges there? And they're very similar to this kind of like separate and siloed data sources. It takes too long to extract and visualize data. Meaning, even if you have it and you have tools, if you don't have technology that allows you to do it at speed, you again might be going too slow in order to actually act on that insight. Multiple tools and systematically different algorithms. So, from a SaaS perspective, we like folks to use SaaS throughout the entire analytic value chain. You don't have to. But what we focus on is kind of making sure that our data integration all the way to the app layer works as seamlessly as it can. Meaning, we do the software development. We don't want our clients to be software developers. We want our clients to be consumers of analytics, not software developers. And that goes well kind of like with common organizational goals. And again, these are like, this is not me talking, this is our customers talking when they're talking about, and these are relatively analytically mature organizations that I'm talking about. Democratization and accessibility of data, analytics, and insights, meaning having broad-based access to the data that the organization have. Not very intuitive. Having access to the analytic tools, meaning they don't just sit on a desktop in somebody's department that isn't mine. And being able to act on those insights. Leverage all the data that you already have. It's really not oftentimes about getting more data. It's making sure that you actually have access to your data and be able to aggregate the data that you already have in your organization in a meaningful way. Apply advanced methods. It's kind of what I talked earlier in terms of, you can program that, or you can be a consumer of the programming. Talking about machine learning, data mining, model management. When we are talking about big data, you end up with variables. You have to really step away from a priori designing your models in terms of want to test X, Y, Z. You can still do that, but you're not going to be able to do that at scale, meaning with all the data that you have, you do want to have technology do a lot of the analysis for you where you can. And also integrating technologies, that it be storage, you mentioned the Hadoop, speed, cost, agility. By agility, I mean, we at SaaS, we embrace other technologies. So, if you want to program in R or you have Python algorithms, that's great. Our technology is not there to kind of like confine it to SaaS. Our technology there is to enable analytics. And, there are ways to integrate all of these pieces. So we work really globally on making sure that we don't create kind of like a closed SaaS system. We want to create a system for our customers that allows the customers to be very effective in the analytic approaches. That means including like a modular approach in terms of being able to use other third-party vendors of software or of programming approaches that they might be comfortable with or they require for their business. So we really focus on being very agile. Ultimately, we are seeking the disruptive information. I have the luxury of working on a lot of these topics internally. For our clients, that's key. So having said all of that, when we look at our clients and I talk to them, usually they fall into two camps. One is a scarcity mindset and one is a mindset of abundance. What does it even mean? Well, on the scarcity side, you're talking about data and technology constrained. On the abundance mindset, data and technology empowered. It's kind of like the difference that I said before in terms of how does like an eBay facilitate analytics versus a health system. And it's not so much kind of philosophically that folks don't want to do it. It's more kind of like, how have organizations come up? a health system such as the Cleveland Clinic has been around for an awful long time, longer than eBay has, or than Amazon has, or some of these other companies that we'll see are very effective in terms of leveraging analytics and data. But we do want to take those lessons on how are you very effective in leveraging analytics and data, and switch over from a scarcity mindset environment to a mindset of abundance. But it's really not just kind of like the access to the data and technology, it's also kind of like, what is your philosophy to analytics and your ability to drive insights? It's kind of like, are you process-centric or discovery-centric? Meaning, do you plan everything? Do you ask every question? Do you have to have the hypothesis? Or do you enable your organization to identify ways creatively that might actually be derive insights that you couldn't plan for ahead of time? Focus on cost control versus focus on value. That's a big deal as well. It's very difficult sometimes when we are talking about doing analytics to actually credibly be able to say that you are driving something that is valuable to the organization. You have to be able to do it to discover the value. If you're only about cost control, you have to have a very high certainty of the outcome for you to be able or willing to actually, do the investment in technology, do the investment in your software, do the investment in changing your processes in order to derive some of that value. That's one I like. Everything is forbidden unless it is permitted. Everything is permitted unless it is forbidden. Now, in some industries, that's all good. As I said, in healthcare, well, there's a reason why some things are forbidden. It could be, safety events for patients. You want to make sure that what you do is actually safe. You want to protect data, so there are reasons why things are prohibited versus allowing broad-based access to it. But still, it's a mindset of, do you try to be as open-minded as an organization to analytics and be able to access it as possible, or do you have to, or are you somebody who has to have very clear vision and insights onto kind of like predictably the insights that you want to install? Well, that's not disruptive. It's kind of very reactive when we're going back to Moneyball. It's kind of like nobody knew a priori that by mining all that data and building a team like that you would be successful. Somebody actually had to take a leap of faith to do that. I'm going to skip over that. So with that, I'm coming back to, I call that SaaS as a platform. If you don't have SaaS on the platform, it's fine. Call it analytics as a platform. But the message that, I'm seeing resonate quite a bit and that I encourage you is to think of analytics as not just a discrete event where you're building a model or you're building a dashboard or you're integrating data. It's not or, it's and. It's building data models and doing analytics and building dashboards. And if as an organization that is not core to what you do, SaaS can potentially help. We will do the software development for you. Because when you integrate processes around data, analytics, and visualizations, you inherently are building software. That's what software is. Software is capturing processes in an automated fashion. So that's where, when we take the analytic approach where, I just put some things on there within each of your organizations, you can probably put your own business questions up there, is A, being able to position our core technology to enable you to solve those business problems or solve those business problems for you or with you. Lastly, when I think about analytics on kind of like the global basis, it's kind of like, who do I focus on? I really focus on the power users and the executive users. Power users, many of you, it's kind of like the folks who know the data best, who knows analytics best, as well as the executive users in terms of those that actually have to make decisions on it. So once in an organization, you really are able to empower both of these groups at the same time with the same technology on the same language with the same insights. These are the organizations that predictably drive the biggest impact. And we go back to kind of like, the way that I sum it between shared, enabled, and transparent. So with that, I want to open it up, for more questions if you have it. Yes? So the question was, how does the healthcare industry start sharing data? So where we see that is kind of like the transference of risk, meaning, those that underwrite risk and those that deliver against the risk. Traditionally, it's an insurer or an insurance company underwriting the risk, meaning you pay money to an insurer, and the physician gets paid for doing something. Well, within the great healthcare transformations that we are going through right now, we have more and more desire to actually push that risk down to the provider and even down to the patient. And in order to be able to take on that level of risk, meaning I'm getting paid for having a very efficient knee or hip replacement, for example, or I'm getting paid for avoiding critical events like a heart attack or a stroke, I need to be able to actually predict out those events. I need to know what is it that I'm expected to mitigate. And in order to do that, you do have to share data between those entities that want to share risk. So ultimately, as the business models are aligning around shared risk, that will facilitate the data sharing, in my opinion, in healthcare. Yes?
I'm sorry, I had to step out for a second, so you might have addressed this question, but can you discuss nurse analytics? I mean, at the caregiver level, how are people using analytics? You seem to be discussing large global issues, but at a very microeconomic issue, let's say I'm a nurse, how do I use analytics?
No, that's a very good question. So we can go back to ultimately, the big data question, for example, being able to predictably use all the data that is ultimately being generated within, if you are within a hospital, that is generated at the time of care as well as integrated data on the patient as it arrives. So a patient that might have been in your health system before or might have been there, so that you know that you leverage the disease history of that patient, who that patient is, and you match it up with the real-time data such as blood pressure data, temperature, et cetera, all of the data that is being generated. And we all have seen that where you have alerts coming up within your EMR systems that ultimately trigger kind of like a call to action even at the nurse level. So what we are working on with organizations is to make those alerts really meaningful so that you don't have alert fatigue, meaning alerts are popping up that are not meaningful. So we are trying to work with organizations, and we work with one specific very large health system on identifying predictably how do you really use the data that you have and translate that through into alerts that are really meaningful to the workflow. So it could be for a nurse, how the nurse is delivering care at the point of care. There's quite a bit of emphasis specifically around like discharge planning and discharge facilitation and post-discharge care for a patient. Again, that might not specifically address your question around, how does it impact the nurse, but that addresses the question on how does a nurse that kind of like stays with patients or is in a patient care program, how do they interact with patients and what do they do? It all comes down to, the multi-constraint optimization problems that I mentioned earlier. Which patient do you give what intervention when? So what we are focused on is being able to integrate all the data, takes the data as it streams in from some of these devices, being able to build meaningful business triggers or meaningful triggers that basically trigger these type of alerts that a nurse reacts to. And by meaningful, I mean it's kind of like that's not where analytics stops. It's not where you define the trigger. It's where you see how that trigger actually influences outcomes. And that's specifically where we are focusing on, was it a meaningful trigger? How do I take out the non-meaningful triggers? How do I identify a trigger that actually has the biggest outcome on, or biggest effect on the outcomes that I'm ultimately driving? And oftentimes also as you're devising that, as the data comes in, what other triggers can you actually identify that you haven't considered before? Yes?
Thanks. With the ACO phenomenon where you're seeing, payer providers, combining their efforts and seeing things where you have multiple silos of historic systems there, identifying patients in one set of systems versus identifying them in, let's say, a payer system, these type of things. You're having to uncover a lot of new challenges with patient records, patient identification. As you start uncovering that, is SAS working on some data models or some routines or algorithms that could help in those transitions, and tying it back into like some managed care programs where you can see, improved outcomes, reduced costs, all of those things start coming together now when you're trying to see, improved health and lowered costs?
Yeah, so the answer is yes, and we're doing it via two ways. One is, if I go back to that picture, we have enabling technology. Ultimately, what SAS has always provided was enable folks to basically be better around data management and be better around getting insights. So we're working with organizations on managing their data management challenges, as well as working with organizations on how to put the ontologies and taxonomies, for example, within the data, how to influence the workflow and get that workflow data as well. So one thing is we're working with organizations on exploring how our technology best solves those needs. So that's one. The second one is we are very actively looking at which one of these specific kind of like applications should SaaS have in a box, meaning we can bring that to, let's say, a provider system where we can say, we cannot just enable you for you to be better on predicting, readmissions risk, but we can say, don't buy our technology to do it, buy our solution. We will do the prediction for you. So it's a two-pronged approach. I want to say that it's definitely on the strategic map, and we are working on it. But right now we are probably more heavily on the still enabling function than the delivery of a complete solution function. But where we can, we do. And we are working with healthcare organizations on those issues because a lot of those issues are emerging. It's a joint journey.
We have time for about one more question before we take a break.
What types of reactions are you getting from healthcare administration decision makers who are very cost control mindset when data management solutions are presented to them?
Well, let me broaden that even beyond data management solutions. I mean, within healthcare, it's a very cost-driven environment right now. This is not a high-profit industry at all. So generally the reaction is, show me that it works. The second reaction is being able to identify, does my action actually translate into the values that I want to drive? And within healthcare, we don't really always know that, We don't have an analytic standard. We don't, a lot of this is emerging. We don't always know exactly how it works. So the general reaction is that folks are very reluctant to spend money on things that you don't have a very clear understanding on how it actually drives value in the end. So that is a big one. The other one is, if we are talking specifically on the provider system, a lot of budget is still being spent on EMR integration. So there isn't necessarily like a lot of budget yet or concentration on very specific technologies to ultimately get insights out of the data. There's still a lot of money being spent on generating and aggregating data, not so much getting value out of the data. It's definitely coming. Yeah, that's a very good question. So the question was, what does it require? Does it require hiring an analyst? Yeah, and we do see that. We do see IT groups growing. We do see analytics groups growing. So one thing, that I think about every day, and, this is not a SaaS message, it's kind of my own opinion, is, what is at the core for a healthcare provider? At the core, the core competency is providing care. But when we are talking about integrating data and, acting on data, we're asking somebody who has as a core competency to provide care to also add the core competency of analytics and data management. And that can be a challenge. So for those organizations that have the capacity and the path to derive value out of making that a core competency, hiring the staff and doing it your own and using kind of like foundational tools to build your own solutions makes sense. For other organizations that may choose to not have that core competency in terms of creating the insight, but they might have, they might be on the roadmap of being able to consume an insight. In that case, they may not build internal systems and internal capabilities. They might be looking more for packaged solutions that are implementable.
We're going to take this opportunity to take about a 15-minute break, and we'll resume our program with our panel discussion at about 11 o'clock. So thank you.
Thank you.